Welcome to this Moji Loop installation guide. This guide is for anyone that wants to deploy a non-production grade Moji Loop installation on their local machines to learn more about Moji Loop or set up a functioning dev environment. Note, these steps are also fully transposable when deploying to a remote Kubernetes cluster if desired. This video also assumes that you have the necessary prerequisites installed and configured appropriately. Please refer to the prerequisites within the Moji Loop deployment guide, or optionally, watch the Moji Loop installation prerequisite guide video first before continuing. In this video, I'll be covering how to install Moji Loop on macOS, and it will be assuming that the following prerequisites are already installed on your Mac. Docker, a containerized runtime that we will use to run Kubernetes, kubectl, a CLI client tool to interface with Kubernetes, Helm, a CLI package manager for Kubernetes, and Lens, a desktop admin user interface for Kubernetes. Once again, refer to the deployment guide for more information and links on how to install these. Let's start by configuring Docker by opening the preferences. Under the resource options, we can change the resource allocation for the Docker runtime by modifying the number of CPU cores, with 4 being recommended, and the available memory with 8 GB being recommended. We can make any changes by playing with the sliders and clicking the Apply and Restart button. After Docker has restarted, we can select the Kubernetes submenu. Here we can see the version of Kubernetes, as well as select the Enable Kubernetes box and click the Apply and Restart. This will deploy all these subcomponents for Kubernetes within the Docker container runtime, which we will be using to deploy Moji Loop. This may take a few minutes. Please be patient. Once Kubernetes has started, we can switch to Lens. Here we can configure our Kubernetes context, which is just a label for a specific Kubernetes cluster. This configuration will be loaded from your user's Kubernetes config, which should be auto-populated by Docker. On the context dropdown, you should find the Docker desktop name. Make sure this is selected before clicking the Add Cluster button. Once loaded, one can click on the Nodes menu on the left side panel to see our single node status and its applicable resource allocation. I recommend that you familiarize yourself with the rest of the left panel. These menu items correlate to standard Kubernetes resources, such as pods under the workload menu or even namespaces. Let's move on to verifying that our kubectl and Helm clients are correctly configured. First, let's get a list of available context by using the kubectl config get context command. This should return Docker desktop as an option. It is possible that you may have more than one entry if you have an existing pre-configured Kubernetes context. Make sure the Docker Compose context is set to default as shown by the star marker under the current column. If not, we can use the config use context command to set the correct Docker desktop context if required. Next, let's verify that our kubectl client is correctly configured for the Docker desktop context by running the cluster info command. This will return API endpoints for the control plane and the kubedns service if everything is functioning correctly. Similar to Lens, we can now query Kubernetes resources such as the namespace by using the get command, or even the pods within a specific namespace, such as default, which should return a no resources found response as this is a new Kubernetes installation. Additionally, we can also verify that Helm can connect to the Kubernetes context by running the Helm list command. Similar to before, we should see an empty result set. We are now ready to start installing our Ingress controller. Refer to section 3.1 of the deployment guide for more information. An Ingress controller abstracts away the complexity of Kubernetes application traffic routing and provides a bridge between Kubernetes services and external ones. This will allow us to access the internal Kubernetes deployed Moji Loop services and user interfaces via the Ingress controller. Following the link at the bottom of section 3.1, we can see that there are many available controllers provided by the Kubernetes community. You are free to choose any controller from this list depending on your requirements and the underlying infrastructure for which you have deployed Kubernetes onto. For cloud deployments such as AWS or Azure, you may choose to deploy their respective controllers, which will allow Kubernetes to provision elastic load balancers within those respective cloud providers. However, we will be using the Nginx Ingress controller as per the deployment guide for its small footprint and simplicity for development purposes. The following steps are provided by the Nginx Ingress controller deployment instructions. See the link within the deployment guide. We will be using Helm for this deployment. First, we need to add the remote Nginx project repository to our local Helm clients by running the Helm repo add ingress-nginx command, followed by the repository URL as displayed on the screen. We then force our clients to synchronize the remote repository with our local Helm cache by running the Helm repo update command, which will update all configured repositories, assuming we had configured more. Finally, we can run the Helm install command, followed by the release name, ingress-nginx, and following that by the repo name / the chart name, in this case, both being ingress-nginx. Fortunately for us, this will not be necessary as Moji Loop Helm charts include a standard set of ingress rules that can be customized depending on your needs. If we now run the Helm list command, we should see our deployment listed on screen. For our deployments row, we can see the following columns: its namespace being default, its revision, which indicates how many upgrades have been applied to it, followed by the last updated date, the status showing deployed, the chart with its version, followed lastly by the app version, which represents the actual Nginx version included in this deployment. We can verify the installation by switching to Lens and selecting the pod resource under the Workloads menu. We should see a single pod named ingress-nginx, followed by a unique identifier showing a status of running on the far right. Switching to our browser, we can also confirm that we are able to communicate to the Ingress controller by entering HTTP localhost using default port 80 in the address bar. This should result in a 404 page being returned with Nginx being displayed below. This is expected as we have not configured any ingress rules that match the localhost DNS or root path. Let's move on to section 4.1 Helm configuration of the Moji Loop deployment guide. Before we can install Moji Loop, we do need to add the remote Moji Loop project repository to Helm as we did when installing our Ingress controller. We can do this by running the Helm repo add Moji Loop command from the guide as follows. If we run a Helm repo list command, we should now see the Moji Loop repository returned and also the Ingress Nginx repo, which is currently not shown here. Same as before, we run the Helm repo update command to synchronize the remote repositories with our local Helm cache. We are now able to run a Helm search repo command, followed by the repo name / the chart name. In this example, we are looking for charts that start with Moji Loop within the Moji Loop repository. And here we see a result of filtered charts that have a Moji Loop prefix found within the Moji Loop repository. We can similarly search the entire Moji Loop repository for all available charts by running the same command, removing the / and chart name. Pointing out some useful information here, the Moji Loop / Moji Loop chart at the top of the list is the main composite chart, which contains all the necessary services to run Moji Loop. This is the chart that we will be deploying shortly. You will also see each of Moji Loop's components represented by one of the charts on this list. That means that each of these components are individually deployable via its respective chart if you so wish. Moving on to section 5.1 Moji Loop Helm deployment. We are now finally able to install Moji Loop itself by running the helm-n demo, as we wish to specify a target namespace called demo, install, followed by Moja, the release name, followed by repo / chart, in this case being Moji Loop / Moji Loop, and finally we add an additional parameter to create the namespace demo if it does not already exist. If successful, you will see some useful information now displayed on your screen. Links to Moji Loop documentation, how to query the status of a deployment, and even how to execute test cases and access their logs. Let's switch to Lens so we can monitor our Moji Loop deployment. Select the pod resource under the Workloads menu and change the namespace on the top right by unselecting default and instead selecting demo. You should now see a list of Mojaloop pods being provisioned by our deployment. Here we can monitor their progress by checking the status on the far right. Before we can use Mojaloop, we will need to wait for their statuses to turn to a running state. This may take anything from 8 to 12 minutes, depending on your system's specification and allocated resources. Please be patient. Let's speed up time by 5,000% by the magic of video editing. After 6 minutes on my MacBook 2019 model, all our pods are now in a running state. If we run the helm-n demo list command, we can see more information about our deployment, including the application versions for each of the deployed Mojaloop components. Alternatively to Lens, we can also use the kubectl-n demo get pods command to query the status of our pods. Let's verify the Mojaloop ingress rules as found in section 5.2 of the deployment guide by first adding the following DNS entries into your local host file and then accessing a few of the Mojaloop services and UIs in our browser. I will be opening my etc/host file in Visual Studio Code, copying the DNS entries mapped to my local host from section 5.2 and pasting them into my host file at the bottom. Note that you will need elevated sudo permissions to persist this change for it to take effect. Here you can see each of the DNS entries that we have mapped to our local host IP of 127.0.0.1, such as the testing toolkit, which we'll be using in our next video to verify deployment, or the ML API adapter, which handles inbound FSP IOP transfer requests. If we open http://ml-api-adapter.local/health in our browser, we should see the health status of the service. This indicates that our Ingress controller and Ingress rules have been correctly configured, and more importantly, our ML API adapter service is operational. We can similarly open up http://central-ledger.local/documentation in our browser to access the inline admin interface documentation. This is a great resource for developers, but take note, not all services provide this endpoint. We can also open http://testing-toolkit.local to access the Mojaloop testing toolkit. As mentioned previously, we can use this to verify a Mojaloop deployment or even write our own custom test cases.